welcome. I see about 60 participants. And well, if you could just briefly turn on the camera so I get a quick overview about who is here, if you don't mind. Usually in my courses, I say hello to everyone, but this is not possible here. Okay, yeah, wonderful. So welcome. I will talk about evidence-based survey operations. This was a topic during my time at GESIS, but currently at the Leibniz Institute for Psychology Information, we are continuing with the work. We're doing a lot of reviews, systematic reviews, and meta-analysis. And let me now share my screen to show you the slides. Okay, here we go. Well, evidence-based survey operations. Let me briefly start with the overall goal and the aims and of my brief talk. I would like to briefly sketch the potential of systematic reviews and meta-analysis to identify generalizable relationships between so-called survey operations variables and survey quality outcomes. And I would also like to briefly sketch the usefulness of meta-analysis for deriving evidence-based recommendations for this specific field. Because as you might know, doing systematic reviews, doing meta-analysis in the survey area is quite rare. And I will address a couple of questions. I will address first the question, what is survey operations? I would also like to address the question when developing a recommendation for survey operations or when making decisions, which kind of evidence should be considered primarily. I will briefly sketch the conceptual foundations of meta-analysis, which is the statistical technique to summarize evidence. I will also briefly sketch which recommendations can be given for survey operations based on past meta-analysis and present 3 studies, the essential of 3 studies I've conducted together with my co-authors out of many other studies, about a dozen studies in this area, meta-analytic studies. And I would also briefly address the question, what are the potential avenues for future research? And I can tell you now that meta-analysis has huge potential for the survey area because there are only a few of these studies available. Okay, but first of all, what is survey operations? Survey operations, sometimes also called in the literature survey implementation, encompasses all the measures and procedures to field a data collection project, to field a survey project. And the overall goal is, of course, to reduce survey errors and survey biases in light of available resources and other restrictions. So as we all know, when fielding a survey project, when planning and fielding a survey project, we are restricted in terms of the budget, in terms of the availability of respondents, in terms of data protection regulations, and so on. And the challenge is to optimize a survey project by reducing survey errors and bias in light of these restrictions. And the core task of survey operations is to develop, to monitor, and to document survey-related study implementations. That's the core task of the area of survey operations. Let me briefly have a look at the different decisions which have to be made on 3 levels: on the level of preparing a survey project, on the level of fielding a survey project, and also on post-processing a survey project. And a typical decision we have to make is which survey mode or which survey modes to use and how to combine these surveys. And we have evidence out there what the best survey mode for a given task is, or the best combination of survey mode to reach certain quality goals. Another decision we typically have to make is the contact and interaction protocol. How does the contact scheme look like to reach respondents and to interview them? Then the incentive scheme. As we all know, incentives are sometimes useful, sometimes they're not useful. There are a number of meta-analyses telling us under which conditions incentives work and whether prepaid incentives work better than post-paid incentives, monetary incentives compared to non-monetary incentives. A fourth decision we typically have to make is how to monitor the feeling period. What is the strategy? What is the documentation? How does the documentation look like? And of course, we have to select staff for interviewer-administered surveys, and we have to train them. And what are the best ways to select staff, and what are the best approaches to train them? There's also meta-analysis currently under development together with colleagues, which tells us what is the best training scheme for a survey project. And on the level of fielding a survey-based project, we have to make decisions regarding the monitoring of the data collection, whether we can somehow predefine certain incidents when revisions of the initial protocols are relevant or necessary, and how to document the fielding process. On the level of the post-processing, when the fielding period is over, data has been collected, how to clean the data, how to finalize the documentation, what kind of bias analysis to conduct, and how to construct weights. And as you know, there's a whole bunch of different strategies out there to construct the weights. And on all these levels, on all these stages, these decisions should be, as I think, evidence-based and guided by principles about what works, what doesn't, and why. And how to identify that evidence. And as you might know, there is a movement, or there is a movement in the health and life sciences, which is called the evidence-based movement, which posits that empirical studies can be assigned to different levels of evidence in terms of quality. There is also a metaphor out there, which is called the evidence pyramid. So evidence is not of the same value. There are different levels of evidence to draw causal inferences. And the second claim they make is that specific guidelines and recommendations should be based on the best available evidence for causal inference. And finally, the higher the quality, the more weight in making recommendations or in considering recommendations this evidence should get. And and that's one prototypical evidence pyramid. If you do a research, you find hundreds of these evidence pyramids, but that's one approach. And at the bottom of this evidence pyramid, and as I said, the evidence pyramid is a hierarchical categorization of study types and designs into different levels of evidence in terms of quality. And the higher, the more reliable evidence, and this evidence should be also considered primarily in making decisions. And at the bottom, you find case studies, case reports, opinions, and beliefs, and they are marked red because that's low-level evidence. Then correlational studies is the next level. They might contain useful information for causal evidence, but because they're correlational, they are of a limited value. And one example of a correlational study we did some 10 years ago was on the determinants of the propensity to participate in mobile surveys, mobile self-administered surveys. At that time, with SMS, WAP surveys, and at that time we already had the first smartphones. And we had a whole array of different factors we considered to be predictive of the propensity to participate in mobile surveys. And at the end, the most important factors turned out to be the expected survey enjoyment. So if participants expect that it's fun to participate in the survey, trust in data protection, and also another factor we call self-image congruity, whether participating in a mobile survey fits to the personality of the respondents. These three factors were most influential. But as I said, it was a correlational design, and we cannot make a strong claim in terms of causal inference and the causal implications, whether these are really the causes of the propensity to participate in a survey. And what was the relevance for survey operations? One claim was to highlight the important factors in communication and also drop the unimportant factors according to this correlational design. is just one example of a correlational design in the area of survey operations. The next level, and we enter the green level, which means more trustworthy compared to the yellow area, quasi-experiments. And as you know, in quasi-experiments, we do not assign participants at random to experimental and control conditions. So sometimes these participants are naturally in one specific stream of the experiment. And there's another example we did a couple of years ago in the GESIS panel, which was a quasi-experiment on prepaid and postpaid incentives. We changed the incentive scheme for one subsegment of that panel. And what we found is that if we have changed from postpaid to prepaid, the response rate were within the panel 78%. And when we had another group which started from the beginning with a prepaid incentives, the average response rate in that subsegment was 91%. And the relevance of this quasi-experiment was use prepaid incentives from the onset in panels. Do not change the incentive scheme later, because then the propensity to respond, the response rate in this case, will suffer most likely. But again, it was not an experiment, and it's also of limited value for causal inference. And now we enter the next level, which are randomized experiments. In randomized experiments, we assign participants at random to experimental and control conditions. They are more trustworthy in detecting causal relationships. And one example of a study we have published a while ago in Public Opinion Quarterly was an experiment on the effects of the length of a questionnaire, of a web-based questionnaire, the announced length of a questionnaire, and also the serial position of items, which we also have rotated at random on indicators of response quality in web surveys. For instance, the completeness of the responses, the willingness to participate, the completeness of the responses, and so on. And what we found in the study was that the announced lengths influenced the propensity to start a survey. The shorter, the higher the propensity to start, but also to complete when actually started. And the third finding we have reported in this paper is also that the serial position of an item affects the data quality. So the later you ask a question, the lower the data quality you get. So if you have important information to cover, put this information more in front or at the beginning of a survey and not towards the end of a survey. So, and the relevance is pretty clear. There's a double impact of length. So length information does influence the propensity to start and also to complete when started. And also the item position, as I said, plays some role. And as you can see in this pyramid, there's something which is even above randomized experiments. And what is above randomized experiments? It's in this notion meta-analysis based on randomized experiments, because single experiments, single studies can also be associated with different kinds of errors, with unsystematic errors, sometimes also with systematic errors. And the idea is these errors can be detected or canceled out. In the case of unsystematic errors, they can be canceled out with a meta-analysis. And in the case of systematic errors, they can be modeled within the confines of a meta-analysis. So at the top of this pyramid, we find meta-analysis based on randomized experiments if we are interested in causal inference. And a study we did quite a while ago, the study had been updated 6 months ago, was on response rate differences in web versus other modes of data collection. And at that time, some 12 years ago, we found that web-based surveys are associated with about 11 percentage points lower response rates compared to any other mode on average. This was the finding at that time, and this evidence had been updated. At that time, we had about 46 experiments considered in the meta-analysis, and now in the most recent update, we had more than 120 effect sizes. empirical findings which we had considered, and later I will show you what the findings were. Okay, and there are other types of pyramids. So pyramids which are based on correlations, because if you're interested in correlational studies and associations, then you can do, of course, a meta-analysis based on correlations. If you're interested in quasi-experiments, and if this level of evidence is sufficient for you, you can also do a meta-analysis based on quasi-experiments and so on. So there are various flavors of evidence pyramids, and this depends on your inferential goal. But we are talking, or I'm talking, about causal inferences, and so the best available evidence is meta-analysis based on randomized experiments for causal inference. Okay, and as we all know, there are too many studies out there, and there are reports about an effect which is called the attention decay effect in science, and you find here a figure where you see an experimental and exponential growth of publications in different areas like medicine, biology, chemistry, physics, and so on. Yeah, and you see because of the scaling here, it's an exponential growth. It looks linear, but it's not, of course. And if we look into our field and ask the question, how many studies are out there which are relevant for survey operations, we find at least 100 publications on incentive experiments in longitudinal surveys. We find at least 200 publications on interview effects in surveys. So empirical publications, and a large share of them also carry experiments. What about non-response experiments and non-response quasi-experiments? More than 300 publications. What about mode effects on response and measurement quality indicators? We have more than 400 publications. So no one of us can digest all these papers. And this calls for a systematic approach to synthesize this evidence. And that's the reason why we at GESIS have established a stream of research which we called evidence-based survey methodology or evidence-based survey operations. And having in mind that our field needs condensed information, synthesized information on the typical findings in areas which are of relevance to survey operations. So now, and the methodology we consider is meta-analysis, which is a statistical procedure to summarize evidence. And I'm not going to dig too deeply into the statistics of a meta-analysis. I would just like to briefly sketch what a meta-analysis is and how meta-analysis is conceptually being performed. So meta-analysis is an umbrella term. There's no single method of meta-analysis. There are so-called homogeneity-based meta-analysis. There are Bayesian meta-analysis. In psychology, we find another approach. We call it the psychometric meta-analysis, meaning meta-analysis encompasses a whole bunch, a whole array of different methods and procedures. And all these methods and procedures describe processes how to systematically retrieve, synthesize, and analyze the results of thematically related studies. So that's the core of any meta-analytic procedure. And what is being synthesized or aggregated in any meta-analysis, be it a homogeneity-based one, be it a Bayesian one, or a psychometric one, effect sizes are being synthesized and analyzed. Effect sizes can be correlation coefficients. It can be standardized differences between experimental and control groups, so-called d-values. In a meta-analysis, you can synthesize also odds ratios or relative risks. So any statistical parameter for which you can estimate a sampling error, a meta-analysis can be performed. So that's the core message. There are meta-analysis for means. There are meta-analysis for percentages. There are even R indicators. Last year we did a meta-analysis on so-called R indicators, and that's also possible. And the overall goal of a meta-analysis is to estimate a true effect which is typically characterized by higher precision and validity compared to any primary study. And that's essentially the message we would like to get. We're not interested in individual studies, we're interested in truth. And because individual studies are associated with different kinds of errors, we need an approach, such as meta-analytic approaches, to model errors and biases on the level of primary studies, and also to cancel out unsystematic differences between studies. And that's meta-analysis. How does the generic procedure look like? So at the beginning, we have a problem statement. We have a specific research question. I will show you a couple of research questions in the area of survey operations later. We have so-called inclusion and exclusion criteria. So which studies are eligible to be entered in our meta-analysis and which studies are not eligible. And to give you an example, in one of these older meta-analysis on web versus other response rate, we said we are only interested in the highest quality level in terms of the design of a study. We are only interested in randomized experiments. So we're not synthesizing studies which do not have a control group, and we are also not synthesizing studies which are quasi-experiments. And that's a typical part of an inclusion-exclusion criteria. Then a decision has to be made what kind of metric you are considering. Do you consider percentage difference in terms of non-response? Do you consider correlation coefficients? How to handle dependent effect sizes? And also a decision has to be made about the data generation model. This is a topic for the next few minutes. Then a systematic retrieval of studies comes into play by doing research in databases about available sources, and also by trying to identify non-published articles. Articles which never saw the light of day, which are perhaps somewhere in a file drawer, electronic file drawer. Then a procedure starts when studies have been identified being eligible. Information is being extracted. So coding form is being applied. The coding form is the questionnaire for primary studies. So the object you have is the paper where your information is being reported, and the coding form is extracting that information from this reported paper. And also a coding manual is being typically developed, telling the coders what to extract from the papers. So what are you interested in? You would like to extract, for instance, response rates. You would like to extract characteristics from this specific study. Where has the study been conducted? What kind of sample did the study encompass, and so on. The next thing is then the core part, the core statistical part. So some people call this initial part, problem statement, systematic retrieval, and coding, a systematic review. And here comes the statistical analysis part. And on the level of the statistical part, effect sizes are being synthesized. So they are being put together. The overall mean is being tested for significance. And then a so-called homogeneity analysis is being performed, asking the question whether all these effect sizes belong together, whether they estimate the same true score, whether they estimate different true scores, whether they come from different study populations. And finally, if heterogeneity is being statistically detected, meaning that these studies estimate different things, then a so-called moderator analysis being performed. For instance, you might come up with the idea that response rates are not homogeneous across countries. And then a moderator analysis would model this heterogeneity by introducing a variable for the different countries. And then you can empirically test whether studies from different regions have different effects. And that's a moderator analysis. And finally, interpretation and communication of results are essential. Okay, let me briefly sketch what data generation model means in the area of a meta-analysis. So typically in a meta-analysis, you do not have access to the entire set of raw data. And in a sense, meta-analysis is a makeshift. So a makeshift for a situation where we do not have access to all the raw data, the primary data of the projects which are of interest for us. And what has been reported in the papers are so-called effect sizes. In this case, correlation coefficients. And these effect sizes are being collected, are being coded. And based on these effect sizes, a mean effect size, in this case, a mean correlation coefficient, is being computed. And statistically, it's a weighted mean, but that's not important for now. And each and every of these effect sizes have a different sampling error. Some of these studies are more precise than other studies. And this information is being used to compute the overall mean. So the overall mean in general, in a so-called homogeneity-based meta-analysis, is being weighted for the precision of the effect sizes. And this mean R is then believed to be an estimate of a true effect size on the level of a so-called study universe. And the basic idea of a meta-analysis is to reconstruct, roughly speaking, the truth. So there's a true correlation, there's a true non-response difference, there's a true effect size parameter, and that's the overall goal. And there are two basic assumptions in meta-analysis. The first assumption is a so-called fixed effect model. And the basic idea is there's one true score on the level of the study universe. Study universe means these are all studies which have been conducted, are being conducted, and will be conducted. That's a fixed effect model. There's one score, and that's the true score. And in the so-called random effects model, there's a distribution of true scores, and that's called the random effects model. And this has to be decided from the onset. So what do you think about the constitution of the study universe? Is there one true score, or are there different, or are there distributions of true scores, which calls for random effect model? And the other thing is a challenge for a meta-analysis is whether there is one true or a group of true scores, or do you have different groups or single true scores? For instance, regional differences. So that's the basic procedure. And the idea is that individual studies are random samples out of the study universe. So the collection of studies you have identified is a sample out of this virtual study universe. And reconstruction is the procedure of a meta-analysis of the true scores or the distribution of true scores. Okay, let me now give you three very specific examples of studies we have performed in the last few years, in the last 15 years. And one of them has been published in Public Opinion Quarterly 1.5 years ago, which is about getting an overview of how many meta-analyses are actually out there in survey methodology. And one objective was to identify previous meta-analysis in survey methodology. That was one of the primary objectives. The second objective of this systematic review was to classify the thematic areas addressed by the meta-analysis according to the total survey error framework. And the third objective was to identify gaps in research and avenues for future research, because our goal was to find out whether the number of meta-analyses published was evenly distributed across the total survey error framework categories or not. And if not, there's a huge potential for new meta-analysis. What we did, and typically in a systematic review, you draw a so-called PRISMA flowchart. A PRISMA flowchart encompasses 4 different steps of identifying eligible papers through screening these papers, estimating or categorizing them for eligibility. And finally, at the end of this PRISMA statement, you summarize the number of effect sizes you have extracted from these papers. And we started from more than 1,000 records. Then we have removed the duplicates. They have been screened for eligibility. And then a couple of these papers have been screened out. And we found 54 manuscripts carrying 60 meta-analytic studies, carrying 91 summary effect sizes which were relevant for our research question. Yeah? And that's a typical structure you find in any systematic review and meta-analysis, at least in the more recent ones, that you precisely describe the steps from identifying sources until you have a set of effect sizes being extracted. Okay, so, and we started summarizing the experiments. So how many experiments have been aggregated? And what you see here is the different topics. We have categorized them according to measurement-related topics and representation-related topics. For instance, processing error, measurement error, specification error. And on the representation-related error side, we have adjustment errors, non-response error, sampling errors, and coverage error. And then we have listed them according to different experimental intervention variables. And what we did, we have simply counted the number of effect sizes being available. And the gray areas are areas which do not make sense conceptually, but the white areas, they all make sense. And if you look at the counts, you see that the combination, having a research question which is on, or an intervention which is related to a contact protocol, has been connected with the outcome variable of non-response error. There are 16 effect sizes available. Mode of administration has been typically connected with the outcome variable measurement error and non-response error. Then we had a couple of identified 3 studies which have manipulated the questionnaire design and connected them with measurement-related and non-response-related errors. And there are a few other studies. And when I talk about studies, I mean meta-analytic studies. So these are not primary studies. These are meta-analyses which are available. And as you can see, and this might also be interesting for all PhD students attending today, is the white areas. A lot of white areas. So there's a lot of potential to do meta-analysis in survey methodology because there are so many white areas out there. These are combinations which would make sense conceptually, for instance, to combine sample characteristics with measurement error, with coverage and adjustment error, but there are no meta-analysis performed until 2018 at that time. And also, if you look at intervention variables such as the technological environment, research respondent interaction, respondent characteristics, and connect them to our outcome variable, there's not a single meta-analysis out there. No? We also looked at the non-experimental meta-analysis. So meta-analysis, the first part was meta-analysis based on experiments. And the second thing is meta-analysis performed on non-experimental study designs. Here we find more effect sizes, and most of them are relating measurement errors with non-experimental variables such as sample characteristics, target population type, and so on, and non-response. So these are really the 2 hot topics in meta-analysis and survey methodology: measurement error and non-response error connected to non-experimental variables. But still, many white areas. So a huge potential for future meta-analytic studies. And also here, no studies connecting non-experimental moderators on the technological environment, respondent, researcher interaction, and so on to our outcome variables. So, and if we look at the specific topics and the evidence which we have identified, the first systematic review on survey operation related topics was published in 1975 in the Journal of Marketing Research. So in marketing research, you find also a lot of interesting studies which are relevant to survey methodology and survey operations. We identified, as I said before, 54 meta-analyses addressing survey operation specific topics. And it's a very low number, because if you look into other fields such as psychology, one journal, which is very high ranking, high impact in psychology, Psychological Bulletin. Psychological Bulletin has about 60 meta-analysis per year. So that's the average, the outcome of a top tier psychology journal per year. And this is the entire outcome in the area of survey operations. So a low number, but to put it on the positive side, a huge potential to do research. And the typical topics being addressed are response rates and non-response issues and measurement differences. And the papers we have identified are not necessarily only restricted to public opinion and survey methodology journals, but you find also very interesting studies in health-related journals, in the life science, in psychology, and also in business research. So it is very interesting to see that these topics are also being treated in other areas which are of interest to us as survey methodologists. And what are the selected recommendations we can extract from these meta-analyses we have identified? And I'm just presenting a few of them. The first is to reduce non-response, use prepaid monetary incentives, and they should be tangible. So there are at least 3 meta-analyses which point into the very same direction. Prepaid incentives do work better compared to postpaid incentives. And if they're monetary and tangible, so non-electronic, not vouchers, tangible, this has the strongest effect to reduce non-response. The second thing is, and there are 5 systematic reviews and meta-analysis out there showing that a pre-notifier and multiple contexts, they work. So Don Dillman was right that pre-notifiers work, and that also multiple contexts according to a specific scheme does also work. Personalize requests and content. Try to make the topic salient for the respondents is also a measure we find as a very effective one. Then avoid offering modes at the same time concurrently, but consider offering them subsequently as a replacement is something we found in 2 meta-analyses. And the 5th recommendation out of many others, but these are the top 5 recommendations we can make based on a meta-analysis, is be aware that the web mode is associated with highest relative non-response rates. And that's something we found in our 2008 meta-analysis. This is something which also was found by colleagues at the same time, meta-analysis which had been conducted in parallel, and I will report now on the most recent results, whether this has changed. To increase measurement quality, be very careful with interview-assisted modes. They are associated with positivity biases. So if you're interested in positivity biases, such as to gain cooperation for panel participation, for instance, it makes sense. But the meta-analysis by Yi, Fulton, and Roger Tourangeau showed that interview-assisted modes tend to have the positivity bias. On the meta-analytic level, again, these are all meta-analysis. These are not individual studies. This is the synthesized evidence. Then use self-administered computerized modes when assessing socially undesirable behaviors, because respondents are less reluctant to report them when computer mediated. And that's a meta-analysis which came out 6 years ago by Timo Knams and his colleague. And this is a very robust evidence that computerized self-administered modes are best when you're addressing socially undesirable behaviors. And what we essentially did is also considering these recommendations based on meta-analytic evidence when creating the GESIS panel. Well, at that time, in 2013, I was the team leader of the GESIS panel. I was in charge of building the GESIS panel. And what we did, we have reviewed the meta-analytic evidence, and we have implemented the findings in designing this panel. For instance, when for the recruitment procedure, we chose advanced letters, pre-notifiers. We contacted multiply. We used intentionally KP interviews because the goal was to gain cooperation. That this was one of the goals. And so we used a mode for which we knew that it was associated with yes-saying tendencies, with positivity biases. We had a personalized interview topic, for instance, during this KP interview, or I'm going one step back. We know that topic salience is important to gain cooperation in surveys. And so one challenge is in a recruitment interview for a panel to personalize an interview. And we did it by asking for different life domains. First of all, the subjective importance of these life domains, whether family is more important compared to your job and other life domains, and the subjective satisfaction with these life domains. And in this KP interview, the product of subjective relevance and satisfaction has been computed. And for the combination where relevance and satisfaction with the life domain was highest, this was the topic of the second part of the recruitment interview. So to show the respondents that this is an interesting panel survey, and this also increased then the likelihood to participate. This was our strategy to personalize in an interview situation. And then we had a sequential mode choice for people joining that panel, because our intention was that those who had internet access should primarily join an online mode. The GESIS panel is a mixed mode survey, and this was then designed in a sequential fashion. And the individual waves of the GESIS panel are also being designed evidence-based. For instance, from the onset of that panel in 2013, we used prepaid monetary incentive tangible. So every second month, €5 are sent to all the panelists. And at the beginning, the GESIS panel encompassed about 5,000 panelists, and they received every second month a letter with €5 being enclosed, because we knew that prepaid tangible incentives are most effective in gaining cooperation. Then we had, yes, there's a euro sign, and who? Yeah, okay, someone wrote it here. There was also a multiple contacting and reminder strategy, and we had a pretty simple design to make participation more enjoyable. Good. But what we also found is, now going back to our systematic review, we found also that current meta-analysis in the area of survey operations could be extended. For instance, we are missing, or we missed studies where the different challenges we have in survey operations are directly tied or connected to quality indicators, yeah? To external validity indicators, to non-response bias, and so on. Many of these studies had only proxy variables such as response rates, and we know that response rate can be a proxy for non-response bias, but it's not precisely non-response bias. Okay, now the plan was to have a discussion, but in view of more than 50 or 60 participants, I think we should move that to the end. And I'm going to present the second study, the second meta-analysis on survey characteristics and representativeness, the generalizability, as a psychologist, I should call this external validity or generalizability of study findings, okay? And this was published in an open access journal, Survey Research Methods, together with Karina Cornès. Karina Cornès, this is part of her PhD thesis. And our question was whether there is an association between survey characteristics and the generalizability of findings. And the research question was, is there an association between so-called benchmark comparisons and R indicators, and whether they are probability surveys versus non-probability surveys? So what is more generalizable, a probability survey or a non-probability survey? And well, we know it from theory, we know it from sampling theory, but one of the advantages of a meta-analysis is a quantification also of the degree of accuracy of a probability survey in comparison to a non-probability survey. So not just is a probability survey more generalizable compared to a non-probability survey, but also what is the degree of bias you are introducing on average when relying on a non-probability survey. Then whether response rates play some role. And now a very interesting question for survey operation. What about mixed mode surveys compared to single mode surveys? So what is the better choice to make the findings more generalizable? Then the number of auxiliary variables being used in the assessment of the degree of generalizability. Yeah, these were the core research questions. And also here, PRISMA Flowchart, we have identified more than 4,000 studies. Then we did an eligibility assessment, and at the end we found 69 articles which had reported the information relevant for our research questions. And what we found is the following, that non-probability samples are of course less generalizable compared to probability-based one. And I will show you later a graphic where you can directly compare them. And this applies for so-called R indicators, and this also applies for the mean average difference between respondents and non-respondents. Then the response rate was also played also a significant role. The next message is that a mixed mode survey is a better choice in terms of generalizability compared to a single mode survey. It's a small effect, but the effect is still there. And web surveys are less generalizable compared to any other survey mode, and also the number of auxiliary variables used in the representativeness assessment played a negative role. So the more information you are using for determining whether a survey is generalizable, the less it is finally generalizable. Here you have a couple of figures, a comparison between a mixed, so the R indicator has a range between 0 and 1. The closer to 1, the more generalizable the survey is, and the mixed mode survey is on average more generalizable compared to the collection of single mode surveys we have identified. And you can see here on the right side that the average deviation is larger for a web survey compared to other survey modes. So you're introducing more bias compared to any other mode when doing a web survey versus using another mode. In the summary, the findings indicate that probability-based samples compared to non-probability samples, mixed mode surveys compared to single mode surveys, and other than web modes compared to web modes are more representative, respectively. There is a positive association between representativeness and the response rate, as we would also expect from sampling theory, but here we have an estimate for that. And a negative association between representativeness and the number of auxiliary variables used. And that's a very brief summary of the second meta-analytic study we conducted. The paper is open access, so you can retrieve it online. The third study I wanted to present is an updated version of our 2008 meta-analysis on web surveys versus other survey modes. This came out 5 or 6 months ago in the Journal of Survey Statistics and Methodology. And the research questions were pretty the same compared to our 2008 paper. So do web surveys yield lower, higher, or the same response rates as other survey modes? Is the mean response rate different, heterogeneous, or not? And do certain moderators explain differences in web versus other modes, such as the sample recruitment base, the solicitation mode, the number of contacts, the comparison mode, the type of target population, the type of sponsorship, the use of incentives, and the year the study was published. And our expectation was that the difference has disappeared. So compared to 2008, people are using the internet, coverage is much larger. It became part of our lives to use the internet. So why should the web-based response rates, or why should the web mode be inferior compared to other survey modes in terms of response rates? This was our initial expectation. Okay. What we did, again, we have identified about almost 300 manuscripts, and after all these screening and eligibility assessment steps, we ended up with 114 effect sizes, which were nested in 97 studies. And these 97 studies were nested in 75 manuscripts. And that's a typical funnel you see in meta-analysis, that you have the paper level, that you have a study level nested within a paper, and then you have an effect size level, which is nested within the study. And that's the reason why the number of effect sizes is typically larger compared to the number of papers you have identified, because multiple effect sizes relevant for your research question are being reported in these papers. So, and what I'm going to show you now is a so-called cumulative forest plot. So meaning we start with the oldest study we have identified, which was from 96, 97. We add the second oldest, the third oldest, and so on. And with this cumulative forest plot, you can visually examine how the evidence has changed over time. And as I said before, our expectation was lower response rates in web mode. This was a problem in the 2000s, early 2000s, in the 90s, but it disappeared over time. So let's have a look what happened. What happened is the following, that you see here, our minus means the web mode has a lower response rate compared to all the others. Starting with this estimate, the second study was fundamentally different. So the mean estimate moved to the more negative side, the confidence interval went up. And the essential message was that there were no significant change in effect sizes since 2002. So the overall difference, web versus other survey modes in terms of response rate, is still around 12%. Yeah? So nothing happened. Nothing happened in the last 18 years, and the estimate has stabilized over time. So if you add more recent experiments and studies, the estimate gets more precise because you have studies added to that, leading to a more precise estimate, but the situation didn't change. We are still with, web modes are still associated with lower response rates compared to other modes. That's one of the key messages. And also we did a number of moderator analysis. Some of these moderators turned out to become significant, such as the sample recruitment strategy, the type of target population plays some role, the solicitation mode, the number of contacts. The more contacts, then the difference goes up. Yeah? So the more you contact for a web survey, the less the web survey will take advantage of these contacting strategies. Other modes will capitalize on a multiple contact strategy more than a web mode. That's also a very interesting finding you find in that paper. And this is a summary of the different moderator effects. So the effect is stronger for new recruitments, for initial participants. So if both modes use a pre-notifier, the difference gets even larger compared to no pre-notifier. So again, and that's a very interesting finding, that if you do something for web and other modes in parallel, the web mode does not profit or capitalize on this intervention compared to the other mode. Okay, so you see, the situation didn't change significantly. Well, there are a number of other studies which might be interesting for today, but because of the limited time, I didn't address these issues. We have other systematic reviews and meta-analysis currently under review on item non-response in web versus other survey modes. This is something which will see the light of day in the next few months. We have also another study currently under review on cross-country differences on web survey response rates. There were 2 German publications, which will be translated in the next few weeks also into English, on so-called conditioning effects. Yeah? So if you ask panelists multiply, if you invite them to a panel over a long period of time, whether their behavior, their responses change. And in this case, we took a look at sensitive questions. Do sensitive questions change as a function of the number of participations in a panel? And in a 4th study, which also came out a few weeks ago, a German one, which, as I said, will be translated, we shed some light on specific groups. In this case, a group which is, of course, very interesting for studies in psychology, participants with affective disorders, and whether the general rules we know from survey methodology do also apply to them. And one of the key messages was that this subgroup does not respond to incentives as we know it from other participants. So if people have affective disorders, they do not react on incentives. You can do whatever you want, they won't. This won't motivate them to participate. There are other factors which for which they're motivated to participate. What are the take-home message? I think that meta-analytic procedures are useful to identify generalizable causal relationships. They should be preferred to substantiate recommendations. So don't rely on single studies, don't rely on opinion pieces or whatever. If you have a chance to substantiate your decisions based on a systematic review or meta-analysis, it's the better choice. And if you have the chance to do a systematic review or meta-analysis on your own, I think it's a valuable thing to do. The few meta-analyses available on survey operation related topics allow for deriving some general recommendations, but they are far away from providing a comprehensive and coherent body of knowledge. And as I said before, there's a huge potential. There's a huge potential for many PhD theses. Perhaps as the first study to get an overview, what is going on there? What does the evidence tell us? How much evidence is available? In which areas do we have robust findings? And what are the areas where we need more primary research? So it's always easier to start a PhD thesis with a meta-analysis. You get an excellent overview of the field and a strong reason to do some primary research because you have detected that some primary studies are still missing out there. There's a large number of primary studies on survey operations topics currently, and as I said, waiting to be systematically synthesized. So again, that's another call to do the work and also to help the community to see the signal which is out there. And future research synthesis should aim for, as I think, directly connecting survey operations variables with survey errors and biases. And this will further increase the practical relevance of the findings. Yeah, and here I've listed a couple of papers on evidence-based survey operations. There were 2 chapters in books. One book has been edited also by Jon Krosnick. I saw Jon Krosnick is also part of the series. There's also a paper about the GESIS panel, about what kind of evidence we have considered in designing this panel, and until today, it survived until today, and it's a success story, the GESIS panel. Then the paper on how much evidence is out there on a meta-analytic level, which appeared in Public Opinion Quarterly. then the paper with Karina Cornes in Survey Research Methods, Open Access, and finally the paper together with colleagues from GESIS and the University of Slovenia in Ljubljana on web versus other survey modes, our updated meta-analysis.